Let us now move on to studying normals to an ellipse. So here we are going to discuss normals. Now we have already discussed in detail about normals while we were discussing the chapter circles and parabola. So the approach would be similar in this case as well. So the first of the three forms, as usual in case of tangents and normals, we study always the three forms. So here the first one is the point form. So basically a point is given to us which is lying on the ellipse, and we need to find the equation of the normal at this particular point. So for that, consider an x-axis, a y-axis, and an ellipse. Let us say there is a point x1 comma y1 lying on the ellipse, and we need to find the equation of normal at this point. So here I have drawn, let us say this is P. So PT is a tangent, and if I call it a point N, so Pn is the normal. So in order to find the equation of the line Pn, we need two things, the slope and the point, so that we can use the point slope form of the equation of straight line and hence find out the equation. So for that, let us differentiate the equation of ellipse to get the slope of the tangent, and from where we will calculate the equation slope of the normal. Therefore, we have 1 by a square into 2x plus 1 by b square into 2y into dy by dx is equal to 0. So this is the equation which we obtain after differentiating. We can get rid of 2, and what we have is y into dy by dx upon b square is equal to minus x upon a square, and from here we can calculate dy upon dx is equal to minus b square upon a square into x by y. So we have the slope of the tangent for the ellipse. Therefore, slope of normal can be written as a square y upon b square x, and hence equation of normal is in the point slope form. So since we are doing everything at a point x1 comma y1, let me put x1 in place of x and y1 in place of y, and hence we have y minus y1 is equal to a square y1 upon b square x1 into x minus x1. So from here we can write y x1 upon a square minus y1 upon a square into x1. So what we are doing is we are dividing both sides by a square, and we have also taken x1 on the left hand side, and on the right hand side we are left with x y1 upon b square minus x1 y1 upon b square. So let us bring the term containing one variable on the left. So what we have here is x y1 upon b square minus y x1 upon a square is equal to x1 y1, and then we are left with 1 by b square minus 1 by a square. So we can also do the following. We can also divide both sides by x1 y1, and let us say what do we have. So we have x by x1 into a square minus y into b square by y1 is equal to a square minus b square. So this is the equation of normal in the point form, because in this equation you will find we have x1 and y1, which are the x and the y coordinates of the point given to us. Now we can also study the second form, which is known as the parametric form, by simply substituting a cos theta in place of x1 and b sin theta in place of y1. So upon doing that, what we have here is the following: x into a square upon a cos theta minus y into b square upon b sin theta is equal to a square minus b square. So we can cancel out 1a and 1b from these two terms, and what we are left with is xa sec theta minus yb cosec theta is equal to a square minus b square. Now this is the equation of normal in the parametric form. After having discussed the point form and the parametric form of the normals, it is now time that we discuss the slope form of the normal. Now, as the name suggests, here the slope is given to us. Let us say the slope of the normal is m, and obviously we are taking and talking about the ellipse x square by a square plus y square by b square equal to 1, and therefore we have to find the equation of normal in terms of m, small a and small b. So let us see what we can do. We know that the slope of normal is given by a square y by b square x, and if let us say the point is x1 comma y1 where we are trying to draw the normal, then the slope can be written as the following, that is equal to a square y1 upon b square x1. Now if this is how m is related to a, y1, b and x, x1, we can write y1 as b square m x1 by a square, and if we put the value of y1 in equation of the ellipse, let me number this equation number 2. So we can write x1 square by a square plus, in place of y1 we can write b to the power 4 into m square into x1 square upon a to the power 4 into b square is equal to 1. So now here we can get rid of b square, and what remains is b square in the numerator. Taking LCM, we have a square x1 square plus b square m square x1 square is equal to a to the power 4, and therefore we can write x1 square is equal to a to the power 4 upon a square plus b square m square, and which gives us the value of x as plus minus a square upon under root a square plus b square m square. Now once we have figured out the value of x1, it is very easy for us to now find y1. y1 can be simply obtained by substituting the value of x1 back in equation 2. So we have y1 is equal to b square m by a square into plus minus a square by under root a square plus b square m square. A square cancels, and we are left with plus and minus b square m upon under root a square plus b square m square. And so what we can now do is, we have the point where the normal is drawn, we have the slope of the normal, and we can simply put that in perspective That is to say, equation of normal at x1 comma y1 is y minus y1 is equal to m into x minus x1. Let us just put the values of y1 and x1. We have y minus plus b square m upon under root a square plus b square m square. This is equal to m into x minus m into x1, which is again the sign will become minus and plus ma square upon under root of a square plus b square m square. On rearranging, we have y is equal to mx. Let us take plus and minus. So m we can take common. We are left with b square minus a square upon under root a square plus b square m square. Now you can also say that in this case the value of c, so if you find that the equation of any line is in the form of y is equal to mx plus c, so you can say that c turns out to be plus and minus m into b square minus a square upon under root a square plus b square m square. If we square this, we have c square is equal to m square into b square minus a square upon under root, and in the denominator we have a square plus b square m square. Now, but we have to be careful here because c square is always going to be positive. We know that b is less than a, so here we need to take a minus sign. That will give us c square is equal to m into a square minus b square upon a square plus b square m square. So this is how any line which is supposed to be a normal, if we want any line to be the normal, so that the y-intercept has to satisfy this particular relation, and the equation of normal in the general form when the slope is given to us will follow this particular equation. So this is all related to normals, and we have discussed now all the three different forms, which gives us c square is equal to m square into a square minus b square whole square upon a square plus b square m square. So this is how c is related to m, a and b. So any line y is equal to mx plus c will be a normal if it satisfies this particular relation, and we also now know the equation of normal in the slope form, and this will satisfy the equation of this kind. So that is all in case of normals. So recall, we have studied all the different forms of normals. First we studied the point form, then we studied the parametric form, and now we have studied the slope form of the normal. We have also found the point of contact of the normal with the ellipse, that is simply given by x1 comma y1. We have calculated the values of both x1 and y1, and if any line is given to you, you also know what should be the value of the constant term in the equation of line when the coefficient of y is equal to 1.